Hello students, I hope you all are good and safe, and I'm going to start my today's session with one more new method. And previously we just completed analytic functions and we did so many practice of these examples, and today I'm going to start with the method harmonic functions, which is again very much useful for the exams. So let's start, guys. The question and the definition is given: let f of z equals to u plus iv be an analytic function. Thus CR equations ux equals to vy and uy equals to minus vx are satisfied. This one we know very well, right? Because this one we did in the definitions of the analytic functions. Okay, that हमारे पास कोई फंक्शन है u plus I v का, and that functions we call as an w or f of z form. And suppose that this is being an analytic function, and now see, अगर कोई भी analytics बन रहा है, then definitely the CR conditions will be satisfied. Then and only then we can say that the given function is being analytic, right? So definitely f of z is given here analytic function, right? So definitely the CR equations will be satisfied. So ux equals to vy and uy equals to minus vx will be satisfied. Okay, now differentiating ux equals to vy with respect to x and uy equals to minus vx with respect to y, we get. Now see, there are two kind of CR equations, right? First one is for the with respect to x, and second one u with respect to y form. So first one equation, which one is ux with respect to ux यानी कि u with respect to x form. This one we are doing differentiating with respect to x. So इसको हम लोग x के differentiate कर रहे हैं, and the rest of the equation we are going to differentiate with respect to the y form. Okay, now doing it with respect to x and y, so definitely here it will be ux, again उसको x के साथ differentiate करें with respect to x, then it will be ux x form, right? And vy उसको हम लोग x के differentiate करें, then it will be vxy as I have written here. Okay, and same for the next one. This one we are doing with respect to y. Okay, so uyy equals to, again here with respect to y, so that will be minus vyx. Okay, so definitely we assume that the second order partial differential equations of u and v exist and are continuous functions of x and y, and thus we have, see, this what they are saying, यहाँ पे हमने जो लिखा है vxy and vyx, these both components are only similar. Okay, we can compare it with both the sides, because if you will do this y v function with respect to y, then after with respect to x, or else this function v with respect to, पहले हम लोग करेंगे with respect to x, then after we will do with respect to y, then and only then the answer will be same always. And this one you might be have learned into the second semester partial differential equations chapter, right? So these both are actual similar terms, so definitely this one will be similar, so that's why we can write uxx plus uyy equals to 0. दोनों का हम लोग एडिशन कर रहे हैं साथ में, right? So uxx plus uyy equals to 0, and similarly we can get, if this one we will do with respect to y, थोड़ा चेंज कर रही हूँ मैं यहाँ पे, अगर ux equals to vy, this one we will do with respect to, यहाँ पे हम लोग y लिखेंगे, और as this one with respect to, here I will write here x, then it will be vxx plus vyy equals to 0. Controversy. Okay, vxx plus vyy equals to 0. So this one is for the function u, and the second one we have found for the function v. So thus we can say that the equation uxx, in short we can write del square u upon del x square. Okay, same here, del square u upon del y square equals to 0, and this y is coming into the 5th or 6th semester constant in the kinetic energy, because all the mechanical branch you will learn into the fluid mechanics with this same function, and this equation is known as Laplace differential equation. Okay, so that's why I have written here in terms of phi, because in that fluid mechanics you will use, in place of xy you will use the operator phi. Okay, so that's why I have written here del square phi upon del x square plus del square phi upon del y square equals to 0, or else we can denote as like phi xx plus phi yy equals to 0, and which is known as Laplace differential equation. And this one is a definition of this exam of the Laplace equation, and which one will be come into the fluid mechanics. I think it's coming in 4 or 6 semester. Okay. One more theory has been given here, harmonic conjugate function, but this theory, the uses of this theory we will use in our next method. But right now just please note that by a Wu definition, if f of z equals to u plus iv, analytic, then u and v both are harmonic functions. Now see, if f of z equals to u plus iv will be analytic, then it will be hyperbolic. अगर वो analytic हो रहा है तो definitely it will be called hyperbolic functions. And in such case, u and v is called conjugate harmonic functions. One more definition has been added. What is conjugate harmonic functions? So hope you all understood, guys. If this one is analytic, then it is said to be harmonic also. Then in such a case, u and v known as conjugate harmonic functions. And here it's given a properties of analytic function. If f of z equals to u plus iv is an analytic function, then u and v both are harmonic. This one we already did in the definition, right? And दूसरी है यहाँ पे, if f of z equals to u plus iv is an analytic, then the family of curves u of xy equals to c1 and v of xy equals to c2 cut orthogonally. It means the multiplication of this both the slope m1 into m2, that will be -1. So there are two properties for the analytic functions, and this one we will do in the examples, so that you can understand more better. Now let's start with the examples, guys. And here it's given examples of the harmonic functions, and the equation is given, if f of z equals to e raised to z, then show that u and v both are the harmonic functions. Okay, here you have to prove harmonic function, and as you know how to prove harmonic function, you have to prove one condition of Laplace differential equation, that is uxx plus uyy equals to 0, or else if you having a function v, because you can see, guys, here is given for both the components u as well as v. So for both components you have to prove these conditions. For the u it will be uxx plus uyy equals to 0, and for the y it will be vxx plus vyy equals to 0. Okay, now see, guys, and for this we need u and v, and u and v definitely we can find from the real and the imaginary parts only, right? So applying f of z equals to e raised to z, and in place of z I am applying x plus iy. So I have written here x plus iy, and now using its exponential rule, So e raised to x into the e raised to I y, because दोनों का base same ही है, right? So we can differentiate into the different forms. So e raised to x as it is, and e raised to I y यानी कि e raised to I theta. So it will be c theta यानी कि cos y plus I sin theta. So यहाँ पे बनेगा cos y plus I sin y. Okay. Now multiplying, now opening this bracket, so that you can get e raised to x into the cos y and plus I into the e raised to x into the sin y. So this is your real part and this is your imaginary part. And now from this u and v you can definitely find its first and its second derivative for u as well as for the v function. So I am finding here guys u with respect to x, again u with respect to one more derivative. Okay, so ux and this one uy uxx, और यहाँ पे आएगा vy vyy. ओके, नाउ अभी u का सिर्फ विथ रिस्पेक्ट टू x ही हुआ है, u का अभी विथ रिस्पेक्ट टू y बाकी है, राइट? सो u with respect to y and again one more derivative with respect to y and as well as for the v, and now we will do for both the conditions, यानी कि uxx प्लस uyy इक्वल्स टू 0 हमें प्रूव करना है फॉर द u, एंड फॉर द v vxx प्लस vyy इक्वल्स टू 0, और वो मैंने यहाँ पे लिखा है गाइस, यू कैन ऑब्जर्व दिस. यहाँ पे मैंने दोनों की वैल्यूज पुट की एंड दिस वन इज बीइंग 0, एंड सिमिलरली आई डिड फॉर द v functions, दिस वन इज फॉर u. So hence u and v both are the harmonic functions. Now second examples, third and the fourth examples. In all the examples you have to find its Laplace यानी कि its harmonic functions. You have to show the given function is harmonic, and now you know very well what is harmonic. To prove harmonic functions you have to show uxx plus uyy equals to 0. So these all the examples you have to do in the assignments. Now let's do with one more example, and the question is given, prove that u equals to x square minus y square and v equals to y upon x square plus y square are harmonic, but u plus iv is not regular. Okay, so regular यानी कि see what is harmonic? Harmonic, it means you have to show that Laplace equations, right? And ultimately you can say that it should be analytic, and for the analytic you have to show the CR conditions being satisfied. Okay, and regular, it means it's opposite. Regular यानी कि it is not harmonic, it's not harmonic यानी कि it's not analytic. When it is not analytic, it means we can say that the CR equations will not be satisfied. Okay, so let's start with the u and v. See here already it's given real and imaginary part, so no need to find again. Okay, so here I have written u and v. From this you can find uxx and uyy. Similarly for the vxx vyy. So यहाँ पे पहले हम लोगों ने किया हार्मोनिक, हार्मोनिक है कि नहीं, सो उसके लिए हम लोगों को करना है uxx plus uyy equals to 0 and vxx plus vyy equals to 0, and you can check that this one is being 0 form. Now to show the regular, to that this one, the given function is not regular, it means you have to disprove the CR conditions, and to show these CR conditions you need 4 components and you have already found it. Okay, so as ux does not equals to vy and uy does not equals to minus vx, you can disprove the condition. It means you can show that the given function यानी कि u plus iv is not regular function. Now next, here it's given a 6 example. The question is given, is the function is harmonic? It means you have to show you have to check whether it is harmonic or not, and for that you have to do, you have to check its Laplace equation, that is uxx plus uyy equals to coming 0 or not. If it will be 0, then it will be harmonic, and if you are not getting 0, then it is not harmonic. Okay, so this one again you have to do in the assignment. Now the seventh one is given, show that u equals to x upon x square plus y square is harmonic. Again you have to show that the given is harmonic or not. You have to prove Laplace differential equation, यानी कि uxx plus uyy equals to 0, that you have to prove. Okay, so you can see guys, here I did ux यानी कि first derivative and again उसका second derivative. This one is too much important guys. See, this all kind of examples, for this all kind of examples always it's need to do derivative. अगर वो ठीक से किया है then definitely you can get proper answer. Okay, and similarly you have to do for the y. So uy यानी कि first derivative and uyy यानी कि second derivative with respect to same only. So here you can see that directly I have written uxx plus uyy equals to 0. It means you are getting that Laplace equation is being satisfied. Now Laplace equations has been satisfied, it means we can say that this is harmonic functions. Okay, so in this session we learned that how to prove harmonic function, or how we can find harmonic, and to prove or to find harmonic which components is needed, right? And so for this all the functions we need only one component, that is Laplace equations, either it is for any kind of function, and this one is also coming for the 2 dimension and for the 3 dimensions also, but in this semester you are going to study only for the 2 dimensions. So guys, now in next sessions we will practice some more examples. So till that, please do the practice of these all examples. Thank you guys.